we have to provide experiences for the kids that let them learn. And that's all we really can do. We can't, just telling them stuff's not gonna do any good. And so we set up these experiences and we help them focus and we ask them what to think about and we get their sort of kind of what they know and don't know, and then we amend what we do, and then real learning happens. And none of that happened in my roller coaster unit. Everybody was building stuff, and maybe they learned a little bit, because it was kind of strange how many of them couldn't fold. Like they couldn't fold a straight line. I don't know why. Or they couldn't tape. With the things we built were four-sided squares of construction paper to hold stuff up. They would cut 4 sides and then try to hold them in a square and put the tape on, okay? Instead of just cutting 5 sides and tucking one under the other and taping it together. And so it was really surprising how bad they were at tape at all. I don't know who was talking about that. They couldn't work the tape at all. So maybe we learned some mundane monkey skills on how to cut and tape and whatever, but there really wasn't content learning like I wanted. And it was my doing. I did it. I fell into the trap of, it looked cool and we were taking pictures and the kids were laughing and I thought it was good, and it really wasn't. And it wasn't because I hadn't taught well. I had good stuff, but I didn't teach well. And that's what happens sometimes with this technology stuff, is we go grab stuff and we're all excited because it's in the coolest box, like, look at that. And because we get away from our fundamentals of teaching, we don't really teach with it. It becomes its own separate sort of thing. We'll call that organized play for today. And there's nothing wrong with that. If you were in the Qublet thing, you might have noticed the first lesson plan for every one of them is open play. Because that's a great idea. As long as you use that kind of as a formative assessment almost, you look and see what the kids can do and can't do, and then customize after that. I didn't do that. I didn't customize anything. I just found out what they couldn't do and then yelled about wasting tape. And so it didn't work very well, even though everything externally looked like they were learning. They didn't know or couldn't do anything they couldn't do before. For the time invested, they really didn't gain anything from it. And it was my fault. I did it. They would have done whatever I wanted because they were into it, but there wasn't any learning opportunity because I didn't teach it right. I didn't structure it right. I didn't progress it correctly. And because I let them down, we ended up with really cool things that we tore down later that no one had any permanent learning from. And so that's what I wanted to spend some time on, was all this stuff is only good if it's part of some progression that makes some sense and leads to some learning. It's not other than the 3 days before spring break, it's not really very useful as a keep them busy kind of thing. It does that, but it doesn't really teach much. And that applies to all the things we have. So we're gonna kind of follow along from simple to complex, because we have all these technology things that can do that, and we can start very simple and get into very complicated stuff. And again, it's not going to be so much grade level. Second graders who use Qubits for the first time are going to do about what 5th graders who use Qubits for the first time are. They're better than adults because they'll just start putting it together. As adults, we worry about breaking stuff and what it costs and things like that. Kids just stack them and see what happens. And we're going to learn how, at least talk about how to go from concrete to abstract. And this abstraction is also like the ability to apply it to something new. So not just abstract like virtual world stuff, but how does a marble rolling down a course have anything to do with a car driven on the road? That kind of thing. And we'll see where that goes. So the part I left out was this part. I didn't have a content goal. I didn't have a purpose for what I was doing. I wasn't purposely teaching. I was helping them play with some rules, and that was about it. And so I really needed this content stuff. I needed the standards. I didn't really have any of those. I had all the words, kinetic and potential, but we never used them. We just built roller coasters. And so that didn't work very well. Okay? And I need the other stuff, the experiences. And I provided them an experience, but because I didn't give them the guidance to know what to pay attention to, they just knew they built roller coasters, and they liked it. They took pictures of them and put them on their own little virtual worlds and did YouTube and whatever, but it wasn't good. And so that was a problem. I didn't help them understand process stuff, the cool skills other than tape. We didn't learn. We didn't learn about engineering because I didn't teach that, and I should have. It was an engineering task, and I didn't follow the engineering model, and I didn't purposely point out that we were. And so like Tony and I have our little book that we'll use next week where we go through the steps of the engineering model and how to define the problem and the criteria and what to do with it. And I had that opportunity and I dropped the ball. And so I have the skills and I have the engineering ideas. I have problem solving. Since I'm on tape, I'm going to try to spell that correctly. So we have problem solving going on, and so that was a thing that we didn't walk through the steps for problem solving. I have them; they're right there. I had them all cut out and everything, and I didn't make any reference to them, and I didn't help the kids see what we were doing and why. So I kind of dropped the ball. And the product, the thing they built. The problem is, without these, this thing was a cool-looking roller coaster that was real colorful. But they couldn't do anything with it. They didn't label where there was high potential energy or high kinetic energy. They didn't show what caused the changes. That's all I had to do. I could have done the same activity and just done it like a teacher instead of like a coach. You know, I didn't do my groundwork very well. And so this is, I didn't help them see the impact or work in a way that showed quality, and I just didn't do it right. And so hopefully that'll give you guys an idea of how to do that better with real purpose. Because one of the dangers of these things is they just looked cool. And it's like, wow, what are you guys doing? We're doing Lightbot. Well, no, you're doing problem solving, and you're using Lightbot to do that. Well, we're doing kubelets. Well, no, you're doing sequential reasoning, and you're using the kubelets to do that. They have to be the tool to the content. They're not the content itself. And that's probably the number one thing that I drop the ball on, is I get the box and I open the box and I'm all excited. I'm like, let's play with this. And so I didn't do a very good job, and I want you to do that. So this is the idea of this simple to complex part. And notice it says simple doesn't mean easy. It just means that you have very little choice. Okay? So the idea of simple is it doesn't do much, so you have to get it to do that. And so when we talk about simple, I'm going to start my kids with simple. I'm going to start my 5th and 6th graders with kubelets. Okay, and actually we're going to start before kubelets, and we'll talk about why. But they do what they do, and that's all they do. And then we'll get into some more complexity later. And the complex doesn't mean hard, but it means open uses. So if you've ever done computer programming, you start with a blank screen, that's complex because it's open to all kinds of things. It's not, you know, a multiple choice test is less complex. And so if you have a cube and all it does is turn a motor, it would be a simple kind of thing. We also want to go across this spectrum of abstract. And so for young people especially, we want to start with physical objects that give them feedback. Did your robot work? Okay, and time is important, you know. If Leslie teaches her kids to build a robot that goes through a maze, if they have to work on it for 45 minutes before they test it to see if it goes through the maze, when it doesn't work, which it's not going to, they've spent 45 minutes of their life, which is a lot. You know, if you're a 2nd grader, that's a lot of your world. And it's like, oh, I'm annoyed. And so we want to make sure that the time investment for trial and error that can be long, but each trial needs to be short. And they need to get some feedback right away. And eventually then, of course, we want them to go to abstraction where they're working with virtual objects like programming and things on a screen and things like that. So anyway, I started with hex bugs. Somebody was talking about hex bugs yesterday. Those things are awesome. Okay, they vibrate around, but they're concrete and simple. They're a physical object. They don't take any time. You don't have to build them. You turn them on, you let them go. Okay? And they're simple because they're only going to do that one thing. They're going to wiggle. That doesn't mean they're bad. They're a great place to start something. They give you immediate feedback, and you get it quickly, and you either succeed or fail in a couple of seconds. And so, did you make it through the maze? Nope. Change the maze, fix the maze, whatever it might be. And so they'll get their play and their experience, and it says the motion is not random and can be guided. So they still have something. You don't want to just do something that's purely random, because that's not going to help either. They don't have any control over it at all. And notice down here it says fun and successful. And that's probably the biggest thing. We spend so much time on this word rigor. We have to realize that we don't want this to be rigorous until they're ready. Okay? We need success first, and that'll be the last slide. So we'll talk about that more later. Then there's something like a remote control car. Okay? Again, it's concrete and controlled, but not. It's a car. It does what I can drive it. I can turn. I might be able to turn on a light, but that's it. So I have a very simple set of things I can make happen, but it's still a powerful thing for kids to have. Okay? And so that might be something that they can work on, because they don't have to design it, they just have to sort of implement it or apply it. And so that would be after hex bugs. And then the little snap circuits, if you've seen these are little things. I think one of the groups was talking about trying to use these. They're more involved because you have to make choices now. It's not just a car. It can light up a light, it can turn a fan, whatever. You have choices. Not very many. There's only like maybe 8 or 10 elements total. But you can combine them together in different ways to make a light light up, a fan turn, a buzzer go off. They always have a buzzer. Those buzzers are nasty to listen to. So the nice thing is you have immediate feedback. The kids click it together and it doesn't light up. It's not, you know, that you were mad at me or she hates me. She always gives me a lousy grade. The light didn't light up. I didn't do that. It's not my problem. You didn't do it in a way that made it work. And so I'm not it falls off, gravity got you. I didn't have anything to do with it. And that's a nice thing for kids because they recognize that it's not because you're out to get them or so-and-so is always giving me a bad grade. I didn't wire it up in a way that made it work. This is the Coded Go mouse. Mr. Pitcher brought me one this morning. You know, so if you haven't seen them, they kind of look like this. Okay, they're a little mouse that you can program to go through a maze. The reason I put them a little bit higher than some of the other things is they're certainly still a concrete device. You're still pushing buttons and driving and things like that. But you control the mouse and you can control the maze. So different ones can make a maze. You could make a maze and I have to program my way through it, and we can interact with each other. So there's thought interaction there that can happen. It's more than just driving a car or whatever it might be. So those are pretty sweet. It also is the first one that has a set challenge. I have to make it through this particular course that Mr. Merritt made, and I have to go through it. Or Mr. Pitcher made one and we switch, and I have to go through his maze and he has to go through my maze. And so there's a lot more there. Right? I also put it up here because of the sequential commands. It's forward, forward, right, left, you know, so on. And so because of that, it's more abstract than the others. The button pushing makes something physically happen, but it's an abstraction into the buttons. This button moves the mouse. And that really helps, especially young kids. Excuse me. First graders being able to understand, hey, this button actually makes something physically happen. It's not that they don't know that practice with it helps their brain develop those ideas.